Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy news journalist for over 20 years. This is the question show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. We also do this show live every Monday at 5 p.m. Pacific time. So if you want to come and actually watch the show in progress, be able to ask follow-on questions, definitely join us live. It's a lot of fun. Now, while you're watching this episode, you might notice there's a little code that's up in the upper corner. I'm going to guess it's this corner, but sometimes it's this corner. I never know. That code is a marker for the question, a vote for the question that you thought was the best. So go ahead, as you're watching the episode, just write down the Star Wars planet that you think was the best question, and I will give a shout out to the winner. And so this week, the shout out is to Andrew Geber, which was about having an Earth-sized telescope to image a black hole. Could we have a 2 astronomical unit telescope to image a black hole? And it was a fun question, a great answer, I think. And so that was the one that everybody liked the best. So again, put in the code that you like, and we will give a shout out to the winner next week. All right, let's get into the questions. Timothy Aaron, can quasars appear anywhere in the universe or only near the edges? Quasars are actively feeding supermassive black holes, and they were a mystery for quite a while. We didn't really know what they were. They were first discovered, and astronomers knew that there were this point source of really bright radiation, and they could tell from the redshift that these objects were very far away, but they didn't know what they were. And it took a long time for them to work out the details, and they were finally able to discover these supermassive black holes that were at the hearts of various galaxies, and realize that when one of these supermassive black holes is actively feeding on material, it blasts out radiation in twin jets. And if you have that jet pointed roughly towards us, then we see that as a quasar. And it's funny, actually, if you watch Cosmos, the old Cosmos with Carl Sagan, and he talks about quasars, and he's like, we're not really sure what they are. And that was back in the 1980s. Like, maybe they're black holes, maybe there's something else. And it's interesting how now, here we are, 35 plus years later, we know with certainty what these are, quasars. And you're right, we see quasars really far out. You know, at this point, astronomers know about 1 million quasars scattered across the universe, but the closest quasar is 600 million light years away. So a little over 500 million light years away. And when you think about how light has been traveling to us for 13.8 billion years since the beginning of the universe, and the vast majority of the quasars are much farther away, isn't it weird? You expect if there's 1 million quasars, you would see them at all kinds of distances, but actually we see them farther away. And there is a reason. And the reason is because the universe that we find ourselves in today is a lot less active. There's a lot less galaxy colliding, a lot less star formation, just a lot less gas and dust that is going into brand new stars. And back in the earlier universe, there was a lot more mayhem, a lot more galaxies colliding with each other, a lot of galaxies suddenly blasting tons of star formation, lots of gas and dust falling into the supermassive black hole and turning on the quasar. Now, it's possible that the Milky Way will gain a quasar in the far future when we collide with Andromeda in like 5 billion years from now. As the two galaxies collide, they bring fresh gas and dust, and it could start the supermassive black hole up again as a quasar. But really, we've missed the party. That where we find ourselves in the universe now, 13.8 billion years after its formation, most of the active star formation, most of the galaxy collisions and stuff happened within the first few billion years, and it's been going downhill ever since. And so we see quasars far away because we're looking farther and farther back in time when the universe was more active. Alderaan, this might be the dumbest question asked on the channel. What would happen if we could tow Pluto into orbit between the Earth and Mars? Bad idea, horrible idea, or secretly a genius idea? I promise you, this is not the dumbest question that has ever been asked on this channel. This is a good question. If you towed Pluto into the inner solar system, in between the orbits of Earth and Mars. And obviously you have to avoid all of the gas giants, the ice giants. You have to weave in and out, avoid hitting Mars, and you park Pluto in between Earth and Mars. Pluto would turn into a comet because it is essentially a comet. It is covered with ice. It's a rocky snowball, just like a comet. And so it would grow a tail, and over hundreds of millions of years, it would dissolve away until it was gone. But if you didn't bring it so close, if you brought it beyond the orbit of Mars, out beyond the orbit of the asteroid belt, then it wouldn't grow a tail. And that's because there is this line inside the solar system called the frost line. This frost line is actually right in between the asteroid belt. Anything that is on the inside of the frost line is too close to the sun, and the radiation from the sun will heat up the ice and the other volatiles on this object and blast it away off into space. And essentially, this is why we don't see any ice on the moon. But once you're outside the frost line, then the heat from the sun isn't enough to melt and sublimate the volatiles, the water, nitrogen, things like that. And so it can remain frozen. And it's really interesting. On this line, actually, NASA's Dawn mission went to two different asteroids. It went to Ceres and Vesta. Ceres is on the inside of the frost line, while Vesta is on the outside of the frost line. And so they wanted to see how these asteroids, which are sort of dividing this line between the inner and the outer solar system, would behave. And that's why we see Enceladus and Europa, all these ice moons out in the outer solar system, but we don't see anything like that in the inner solar system. So Pluto would form a comet. It would be beautiful. It would be awesome. We could see it every day. It would be like a forever comet. And I think it is a really awesome idea. Although Alan Stern, the principal investigator of New Horizons, might disagree. And he wouldn't want Pluto evaporating away. But I think it would look super cool. Kevin Dugan. If it costs $10,000 a pound to send mass to orbit, why deorbit the ISS? Why not start an orbital junkyard with future recycling potential? We get this question a lot, and when you think about the $100+ billion that it's cost to build and launch the International Space Station into orbit, it seems like a colossal shame to let the thing die, deorbit, and crash into the ocean and be gone. And it is a shame. But in terms of as a machine, and we talk about this, I get this question quite a bit and have answered it. It is a machine that's getting older and older and run down. It is 20 years plus that it's been in orbit, but parts of it have been under construction for a lot longer than that. And it's going to last until about 2030. So it's going to be about 30 years old by the time it's done. It's like, imagine if your refrigerator was 30 years old, your car is 30 years old. Like at a certain point, you can't do any more maintenance. But what you're suggesting, I guess, is why don't we just leave it in space for spare parts? And the problem with that is sort of twofold. One is that you would have to put in a tremendous amount of energy to raise its altitude into a more stable orbit. Right now, it is coasting through the upper atmosphere of the Earth, and it needs constant reboost to stop it from deorbiting and re-entering the Earth's atmosphere. So you would have to raise it quite high. And it's not like it's just floating out there in space. It is near the bottom of an enormous gravitational well of the Earth. And so you would have to send rocket after rocket after rocket, each one boosting the enormous mass of the space station into higher and higher orbits until you got it, say, to 1,000 kilometers. Because right now it's like, say, 500 kilometers. So once you got to like 1,000 kilometers, then you probably wouldn't have to boost it again for a few decades. Maybe you could get up to 2,000 kilometers, and then you wouldn't have to boost it for hundreds of years. But it would be rocket after rocket after rocket, mission after mission after mission. It would be very expensive. Maybe as much as the cost of building the International Space Station in the first place. I haven't done the math, but it would be a lot. But then, how do you actually extract this material? We don't really have any good way. Like if I just handed the International Space Station off to a scrapyard here on Earth, I'm not sure they would be able to do a lot of they'd may be able to dismantle it, but it is like bits of foam and mylar and steel and aluminum and electronics and plastics and glass and all this stuff all mashed together. And so it would be really tricky to try and turn it into something that could be reused, even down here on Earth, where you can breathe the air and do work in in your t-shirt. I can't even imagine how difficult it would be to do it out in space. And then the other part is that it's still going around the Earth, and you would have to be able to match the orbit of the International Space Station, be able to dismantle it, be able to sequester these parts and pieces and use them for something else. So it's a level of expense and a level of complexity that NASA is just not prepared to do. But we're not going to lose the entire station. There's going to be a commercial module attached to the Axiom module, which is going to allow for space tourism and other stuff. And when it detaches from the International Space Station, it's probably going to take some of the newer modules with it, and NASA's going to continue to maintain those. So I'm not sure sort of what will remain after 2030. And then the other big unknown is what's going to happen with Starship. It could be that Starship totally changes the game, and it makes a ton of sense to detach the modules, gobble them up into Starship, bring them back down to Earth. Maybe you could do that in a couple of months. We don't know. So right now there are no plans because it's just too expensive and not really feasible, but who knows what the future may hold. Richard Davison. Assuming we had a powerful enough telescope that could see an object from 13.7 billion years ago, would that object be visible from every direction in the night sky, essentially being magnified to cover the entire sky? No, but it's a really good idea, and astronomers have tried this. So there's kind of two possibilities for the universe. The one possibility is that the universe is infinite. And what that means is, like, at the beginning of the universe was infinite, and then you had the Big Bang, and the universe got less dense over time, but it was still infinite. It's infinite today. In other words, if you travel in any one direction, you will never return to your starting point. You just go on forever in any direction. But the other possibility is that the universe is finite. But it is finite. In other words, if you go in one direction long enough, you will pop out the other side of the universe and you'll return to your starting point. In the same way that if you go in any direction on the Earth, you will return to your starting point. And astronomers have looked for this. They've said, well, if we look off to the left and then map out the structures that we see on the left, and then we look off to the right and we map out the structures to the right, are we seeing mirror images of the same thing? Are we seeing something from one side and then something from the other side? And the answer is no. In every direction that they see, they don't see any repeating patterns of the universe. You can imagine if you saw, like, you would see like one closer and then one farther and then one farther, just like smaller and smaller versions of it. Then you realize, oh, the universe is only, say, 5 billion light years across, and then we're just seeing it repeating in all directions as we look out there. But we don't see that repeat. In fact, astronomers have been able to measure the curvature of the universe, and they've found that it means that even if the universe is finite, it is vastly bigger than the universe that we can observe. And so if the universe was finite and it was smaller than the observable universe, then we would see a repeating pattern in all directions. And we don't see that. And so we know that the universe is bigger than we can see. Ruling Moss 55. What's your personal favorite theory for what lies beyond the observable universe, even if it's not the most realistic? My personal favorite that's not realistic? I don't really have one. From what we understand, or the assumption that astronomers make, it's called the Copernican principle. And the gist is, you're not special. We're not special. That we live in a typical planet, in a typical star system, in a typical galaxy cluster, in a typical observable sphere of the universe. And if we were to transport ourselves to any other place in the actual universe, not the observable universe, but the full universe that could be infinite, then we will see roughly the same thing. We won't see the same planet and the same stars and the same galaxies, but we will see galaxies arranged into clusters. Inside the galaxies or stars, there'll be some that are bigger than the Milky Way, some that are smaller, with roughly the same number. But the idea that I do like is that if the universe is infinite, then that follows that things that are finite, like planets, stars, particles, etc., will start to repeat the farther that you go. And so if you go far enough, and like really far, you will come up with another version of the Earth and another version of the solar system. And eventually you will come to a complete copy of the observable universe as we find ourselves there. Not only that, but you will find it an infinite number of times, just repeating. And again, the distances are absurd. Like, we don't have numbers big enough to measure how far you would have to travel to find one of these repeat universes. But the math holds that not only would they be out there, they would be out there an infinite number of times. And so I think that is my personal favorite idea for what lies beyond the observable universe is an infinite number of universes just like ours, and with every possible variation in between. It boggles the mind to think about it. Shane Squires. If an asteroid is deflected from the Earth in between the sun and the Earth, won't it pull us closer to the sun, thus burning us up? So I'm sort of imagining that you get this asteroid that comes really close to the Earth and it does a flyby from the Earth. And by doing so, it deflects the Earth's orbit a little bit, and then the Earth spirals in and hits the sun. Is that sort of what you're imagining? The answer is no. And the reason is because the way orbital mechanics works is that, according to Newton's laws, right, an object in motion tends to stay in motion, that when you are in orbit around the sun, you're going to follow this precise orbit unless some other force acts on you. And so in the case that you described, you got this asteroid that's coming very close to the Earth. You know, the gravitational pull of the asteroid is that force acting on the Earth. The Earth will change its orbit slightly, but then the asteroid is gone and the force is no longer acting on the Earth. And so now it's got this tiny little change, like maybe it's a millimeter change to its trajectory. Now you can imagine a more extreme version. Let's say a black hole came relatively close to the Earth and really wrenched the Earth out of its current orbit. But once the black hole was gone, the Earth would be on a new orbit and it would just be following this new orbit forever unless some new force acted on it. The only way the Earth could actually fall into the sun is if the sun became a red giant and the Earth fell into the atmosphere of the sun. And now the Earth is inside the outer atmosphere. The friction is constant. It's constantly being slowed down, and it would lose its sort of altitude from the sun. It would eventually spiral in. Now, this idea of using asteroids to move the Earth is kind of cool because you could use this method to save the Earth from when the sun becomes a red giant. You would have an asteroid come by the Earth every, say, 10,000 years. It would impart a little bit of orbital momentum to the Earth. It would raise the Earth's orbit a little bit, changing it, and now the Earth would be on a bit of a higher orbit, but it would still be it would be stuck there. And then 10,000 years later, you would bring another asteroid by and raise the Earth's orbit a little bit, and you could time that so that as the sun is heating up and expanding outward, the Earth is constantly being pulled farther and farther away from the sun, maintain the same temperature, and you would be able to be stable. So the only way that you would have this situation where the Earth is actually going into the sun is if that asteroid just kept coming by year after year after year and was constantly pushing the Earth, giving it, changing its orbit so that it just kept slowing down and getting closer and closer to the sun. Landon Runseval. How often do dust storms occur on Mars? Are they a threat to colonization? Dust storms seem to happen a lot. There are localized dust storms on Mars that happen every few months. And we know that every couple of years, these storms will rise to the point that they cover the entire planet and choke off the sun. And when these dust storms are happening, they're pretty bad. Now, it's not about the wind. I mean, the wind on Mars, you could go out in a hurricane and you couldn't even fly a kite because the density of the atmosphere on Mars is so low. But the problem is that they blot out the sun. And this was the thing that killed Opportunity just a couple of years ago, was that it was out doing its Mars rovery thing, and one of these global dust storms, one of the worst ones that we'd ever seen, came over the planet and blocked the light, cut off all the light to Opportunity's solar panels, and then it wasn't able to maintain its heaters on board so that it could handle getting through the cold nights on Mars, and it died. And so the risk for a Mars colony would be that you have this global dust storm and it is going to block the light on your solar panels for weeks, maybe a month. You're going to have reduced sunlight on your solar panels. And so can a Mars colony survive for an entire couple of weeks without really any sunlight getting through to the solar panels? You're going to need a backup power system that can handle that level of loss of sunlight. And so I would say that is definitely a threat. You're going to need a backup power system capable of getting you through a dust storm. Think about plants. If you're growing plants in the greenhouses, you're going to have no sunlight. All the plants are going to die. So definitely a risk, and people will have to figure out a solution if they're going to plan to live there for years at a time. More questions in a second, but first I'd like to thank our patrons: Christopher Kerp, Nick Piplica, Rita Derrick, Don Boak, Nikita Joseph, Nick Korn, and the rest of our 1,047 patrons for their generous support. Want our videos with no ads? Join our community at patreon.com/Universe Today, and I'll also remove all the ads from Universe Today for life. Axel Cowald. Hey Fraser, don't you think that the solar gravitational lens is perfect to detect technological civilizations? It also bends radio waves, and thus we can detect their communication. Yeah, the solar gravitational lens is the best way to detect anything. Now, if you haven't seen it, I did an interview with Slava Turashev here on the channel about the solar gravitational lens. And the idea is that you send a spacecraft out to about 500 astronomical units from the sun. And at that point, the gravity of the sun acts like a natural lens to whatever you are aiming at. And it gives you a image of an exoplanet, right? Another Earth orbiting another star that is hundreds of light years away. You get a megapixel image, 1,000 pixels by 1,000 pixels. And from that, you can see clouds and oceans and deserts and mountains and all kinds of things. And you would be able to see the lights of cities. You'd be able to see various forests, all kinds of definitely technological civilizations, definitely if there was life. And yes, if they were sending out radio signals, those would be focused as well, and you'd be able to receive them. So, but like the solar gravitational lens is the perfect answer for literally anything that you want to observe. Wouldn't it be great to observe the event horizon around a supermassive black hole? Or even just a regular mass black hole? Wouldn't it be great to observe a pulsar? Wouldn't it be great to observe a red giant star that is in the last days of its life? A white dwarf that is rapidly spinning, consuming. Yes, the answer is yes to all of these questions. So I think we need solar gravitational lenses, as many as we can send out, as much as we can afford. Yes, please. Rose H2O. Should we be worried about a major asteroid strike on another planet? Would this cause any harm for our own? No, we don't have to worry about a major asteroid strike on Mars or Mercury or Venus. Yes, if it was really bad, then maybe it would kick up a lot of debris. If it was really bad, if Mars crashed into Venus, then that might be an issue. But there's nothing out there that's big enough that could cause enough damage that would be an impact for us. Even something really big smashing into the moon wouldn't be that big of a problem. But if it was like another moon smashed into the moon and broke it up, then that would be a problem. So no, I can't imagine any situation that an object getting hit out in the solar system would cause any debris, significant debris, to come to Earth. Aaron Calhoun. Can a moon of a gas giant in the habitable zone of its star be far enough from the magnetic field to still be habitable? So I guess what you're imagining is, say we had a planet like Jupiter and we had a moon that was orbiting around it, but the Jupiter is orbiting within the habitable zone of the star. And so in theory, you could have liquid water on the surface of this moon. And I guess the problem with Jupiter is that because it has this enormous magnetosphere, it creates this incredibly dangerous radioactive zone around Jupiter where if you tried to live in there, you would be bathed in radiation all the time? And the answer is yes. Yeah, if you were far enough away from Jupiter, like farther than Ganymede, farther than Callisto, if you were significantly far away from the planet, then you would be outside of the dangerous parts of the radiation. Now, you would probably still want a magnetosphere. You would absolutely want a magnetosphere for your moon. So it would have to be like Earth-sized, and then it would be able to generate its own magnetosphere, and that would protect you from solar storms, from cosmic radiation, and the magnetosphere of Jupiter, or your gas giant planet, if it's able to reach out. But yeah, there's no reason to think why you couldn't have a habitable moon orbiting a gas giant and have life on it. Ted Krause. Hey Fraser, what is your take on the new interest in the UFO by NASA and other interests? I don't really have an interest. I reported on this news last week that NASA is doing a report on this UAP phenomenon at the same time that the U.S. military is doing that. And I have seen enough perfectly reasonable explanations for the kinds of things that people have seen that it doesn't seem surprising to me that you could have a perfectly reasonable explanation for every single one of the things that have been seen. They're birds. They're mylar balloons. They are an error on the instrument. So I think you could probably explain all of the issues, all of the things that have been seen with enough time and investigation. I think it's possible that there could be exotic and advanced aircraft systems, but that seems unlikely to me. Like, I think, like, if the Chinese had a spacecraft that was capable of going at tremendous velocities, we would know about it because it would be used as leverage for negotiations and diplomacy and for projecting power across the world. Like, if you've got that kind of like, we know that the Russians have the ability to launch nuclear weapons. They make it very obvious. They bring it up a lot because it is a bargaining chip. So I don't really believe that anyone on Earth has technology that's beyond what we are roughly aware of. I'm sure people have advanced composite materials for their aircraft and so on and so forth. And I definitely don't have any reason to believe that aliens are visiting the Earth. But, I'm perfectly happy to be convinced otherwise. I spend so much of the time on this channel talking about ways that we could search for life. I would love any kind of evidence that would make me feel like, okay, great, we're not alone in the universe. We've got a sense of what's out there. And right now, I just don't find any of this convincing. So I mentioned this before, that the Pentagon's investigation of this would probably be unsatisfying to the UFO crowds. And I think that the NASA report will also be unsatisfying to the UFO crowds. You will still get to, it's all unidentified. We don't know what it is. And, there are a lot of instruments. Everybody's got a smartphone. People can observe the night sky. There are tons of all-sky cameras that are watching the sky all the time, from observatories, astronomers, NASA, etc. You've got satellites in space that are observing the ground. And so if there were the kinds of things that we couldn't explain, we would already see a lot more information from NASA and other agencies. So I don't think we're going to learn anything new. I think it's just going to be more unidentified flying objects, and the conspiracy theories will probably continue. And so if you believe in them, then you probably think that nobody's going to be giving a straight answer, that classified information is going to remain classified, and the whole process is pointless. And I don't know what to say. Luke Gunther. Is it possible to create a human-made meteor storm for an event like New Year's Eve? Send a spacecraft ahead of the Earth's path and dump a bunch of sand. Yes, it is. And it has actually been proposed by I think it's a Japanese company, has actually developed the technology to release sand from orbit during some special event, and you would create an artificial meteor shower. I think it's a terrible idea. I think it's awful. that you would cause more light pollution. But, as long as it was brief, it was over a fairly localized area and you could really control where the sand was coming down. But you wouldn't need to go ahead of the Earth's orbit. You just have to be in orbit around the Earth, and you just have the right time fire down the sand to enter the Earth's atmosphere, and you would get a crazy meteor storm wherever you wanted it. So the technology is definitely possible. I think the light pollution implications of it are pretty bad. So I would want someone to give me some assurances that it's not going to be bad for the environment and bad for just like light pollution. Stephen Keeley. Hey Fraser, if you could teleport anywhere within the galaxy for 24 hours to explore, where would you go and why? I'm going to give you a really unsatisfying answer, which is that I don't know, because we just don't know very much about the galaxy. Yesterday, we got the release of the third data package from the European Space Agency's Gaia spacecraft, and they charted 1.8 billion stars, like well over 1%, almost 2% of the stars in the Milky Way. And it's very impressive how much of the galaxy has been mapped. But when you think that it's only 1 or 2%, then there's 98% of the galaxy that we haven't even observed their stars. And so out there in the galaxy, there are wonders. There are, even just like if there isn't life, like if there are natural features, there are planets that are extremely large, places with moons. There are canyons and giant craters and volcanoes of metal and stars that are gobbling up their planets, and things interacting with black holes and white dwarfs and pulsars and multiple star systems and planets orbiting around multiple stars and it goes on and on and on. And so if you tell me like where would you go and why, like I don't know, because we know so little about the whole Milky Way. We just really know a little bit about the solar system and a lot about Earth. So the places that I know of where I would love to go are located in the solar system because that's all we know. So I'd love to go to the TRAPPIST-1 system and see multiple Earth-sized worlds orbiting in the sky relatively close. It would feel like a science fiction movie. You're standing on this planet, you're looking up into the sky, and you're seeing other Earth-sized worlds hanging in the sky. That would be kind of amazing. I would love to stand on Europa and be able to see Jupiter enormous in the sky, or stand on one of the moons of Saturn and see Saturn right there. I'd love to stand at the edge of Valles Marineris on Mars, the deepest valley in the solar system, and be able to just appreciate how enormous that place is. So I feel sad. When you ask me that question, my first feeling is disappointment, because I don't even know what would be cool, because we just haven't explored more than a fraction of the Milky Way. Joe Lee. Hey Fraser, is it possible for the Hubble telescope to look at the James Webb? Yes. Hubble could look at James Webb and see one dot and could confirm its existence, and that's about it. And who knows, maybe at some point James Webb will happen to be in the field of view when Hubble is looking at something, and we'll get a note like, hey everybody, we happen to catch James Webb in our picture. Now when Webb was on its way out to L2, several Earth ground-based telescopes were able to see it. Even some amateur astronomers were able to detect it. So it's not that hard to see. It's not that dim, but you won't see anything more than just a single dot. And that's not super interesting. Zigzag Zarf. Is anyone known to be working on possible construction equipment for the moon, Mars, etc.? Starship makes bringing large construction equipment to orbit for mining and building a possibility. Yeah, some of the big construction companies here on Earth are actually developing bulldozers and excavation equipment that could function on the moon. So specifically Caterpillar, which makes construction equipment here on Earth, they are actually developing prototypes and ideas for mining equipment that could operate on the moon. And NASA has a whole group that focuses on mineral extraction, gathering material, being able to to harvest the resources from it for construction, for building roads, landing pads, things like that. So not only is it possible, but several of the companies that you're familiar with are actually working on technology. And who knows, we might see it fly to the moon in the next few decades, and we'll find out if digging on the moon is similar to digging on the Earth. AR. Are there aliens on the backside of the moon? For the longest time, we didn't know what was on the far side of the moon because the moon is tidally locked to the Earth. And so we only see the one face of the moon. And finally, the first time, the Soviets were able to send a spacecraft into orbit around the moon, and they were able to send back the first pictures of the far side of the moon. And the surprise was that the far side of the moon looks actually quite different from the near side of the moon. Well, the near side has these giant dark regions called mare. The far side of the moon, it just has crater after crater after crater, and it doesn't have those same mare. And exactly why this is happening is still a bit of a controversy. One idea is that the internal structure of the moon is a little bit lopsided, and so you got these lava flows on the one side of the moon and not on the other side. Another idea is that the moon gobbled up another moon early on in its life, and it sort of spread a layer of material on the far side of the moon. But now we have a lot of spacecraft at the moon, and especially we have the Lunar Reconnaissance Orbiter. This is a spacecraft from NASA, and it is orbiting the moon, and it is mapping out the moon at incredible detail. It can see objects that are about a meter sized down on the surface of the moon, even smaller than that. It's been able to image all of the Apollo landing sites. It can even see the footprints of the astronauts as they were walking around on the surface of the moon. And so at that level of resolution, if there were any alien bases, any ancient factories on the surface of the moon, we would probably see them. That said, there have been a lot of interesting proposals that the moon is one of the best places that we could go to search for some evidence, not necessarily of aliens today, but maybe there were aliens in the past. Maybe there was some kind of facility on the moon, but it's been obscured by regolith. Like there's been a lot of impacts and dust has settled, and so it's like you cover things in snow and they become obscured and hard to recognize. And so the idea is that you would take the surface of the moon and you would feed it into some artificial intelligence learning, machine learning algorithm that would scan across the surface of the moon pixel by pixel and look for anything that is unusual, some kind of anomaly that deserves closer scrutiny. And then maybe you could take a better picture with the spacecraft, or maybe even send a rover or a lander for something that's really interesting. So we don't have any evidence that there's anything on the moon, but this exact idea has been proposed, and we could probably see the first study of, based on this machine learning algorithm come out in the next couple of years. And maybe we'll have some really interesting targets that we should study more deeply. DHR-18. ESA is doing a comet intercept mission. Are there any plans for a comet sample return? What will we learn from the earliest water in the solar system? If you look back in my channel, I did a battle with everyday astronaut Tim Dodd about a proposal from NASA. They had to choose between two missions. One was a comet sample return mission, and that was the one that I advocated for. And the other was for a nuclear-powered helicopter to fly to Titan, which is the one that Tim made the video for, which obviously we know now that's the Titan Dragonfly. NASA chose the Titan Dragonfly over the comet sample return mission, which is like obvious, like duh, of course they did. I mean, I gave Tim the more fun one. I chose the harder topic. I also would prefer to see the Titan Dragonfly launch, but a comet sample return mission would be incredible. We've had something kind of close. We had the Stardust mission, which was a NASA mission that flew through the tail of a comet and retrieved particles and returned them back to Earth, and scientists have been able to study those. But to actually dig up a sample of a comet and bring that back home to Earth would be incredibly fascinating. So what could we learn? There are a lot of questions about where the water on Earth came from. I mentioned early on in this episode that if you're too close to the sun, all of the water should evaporate. And yet the Earth is covered in water. So where did that water come from? One of the ideas is that it came from comets. And so you could sample the comet and you could see the chemical signature of the water and the other materials that are in that comet and compare that against the isotopes, the chemical signature of the water here on Earth. And you might get an answer to say, oh, we can definitively prove that the Earth's water came from comets, and maybe even get a sense of where in the Oort cloud those comets came from. Were they like the long period comets, or were they the short period comets, or were there some other class of object that maybe are gone now but were around back in the early solar system? So it would be incredibly valuable. Not as cool as a Titan Dragonfly helicopter to Saturn's moon, but still I would love to see that mission fly at some point. So hopefully the people behind it are going to hang on to their idea and we'll get around to see it actually fly. All right, those are all the questions that we had this week. Thank you everyone who asked questions in the comments across the channel and everyone who showed up for the live show. It's super fun. We do this again every Monday at 5 p.m. Pacific time. So if you want to come and join the show live, definitely come and hang out with us. All right, we'll see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber, Nancy Graziano, and Anton Poznikov.